Hey everybody, Dr. Jensen with CCJ3701, Research Methods in Criminology. So where we left off with binary logistic regression was starting to generate some output. So we're going to review what the SPSS output means. Some of these pieces you can ignore because we really don't report on it when we get ready to talk about our results. And other pieces we're going to focus on because it does become a result. But just like in linear regression, you get lots of pieces that show you the processing or the products of the equations that are being calculated during the technique. Not necessarily something you need to talk about, but it just shows you some of the pieces that are being worked on. And I'll kind of direct your eyes accordingly. Okay, so when you get SPSS output, you get kind of a whole bunch of blocks. The first few blocks you can kind of ignore, all the way to where you get to model summary, and I'll show you this in a moment. Model summary, just like in linear regression, is how does the model do, with R squared. Okay, and we'll talk about what R squared actually means in logistic regression in a minute. But this is where you find the R squared, and you'll find some funky little names in here. You see Cox and Snell R squared, and you also see a name called Nagelkerke R squared. If you want to be famous, in SPSS or in statistics, you come up with a way to calculate an R squared on a technique that is impossible to do that on. And so these guys came up with what we call pseudo R squareds, something that is approximately an R squared. And then their idea caught on, and now they're in SPSS and they're super famous. Okay, but at the very bottom of your output, you're actually going to get variables in the equation box, which has your variables in it that you put into SPSS. You get that famous B coefficient. However, the B coefficient doesn't mean much in in logistic regression. It does in linear, but, we're not graphing a line. It'll still calculate a slope, but the slope is kind of irrelevant. So what we do in logistic is we calculate what we call the exponential B, or an exponent of the slope, okay, because we're doing these estimations, not necessarily a slope, okay. We also refer to this little EXPB as an odds ratio, the odds of something happening or not happening. So in this last box, you do get a significance level right here, but you can kind of ignore this B. We really don't report it. So whenever you get some output on logistic regression, train your eyes to go all the way to the right side and just look at these last two pieces, significance level, exponential B, or odds ratio, okay? So in order to understand odds ratios, you need to understand odds. So this is just a quick little review on how odds work. So remember, when we say the word odds, it's the probability or likelihood of something happening. Okay, so generally you would say what's the probability of success versus the probability of failure. And so we would kind of do a simple mathematical equation to determine that. And then you get a ratio. You're like, I think the Cubs are going to win the World Series 4-1, and they have a chance of 4 times success compared to 1 chance a time of failure. So you'll see little ratios like that, okay? So again, you could do this with passing an exam. What's the chances of something happening, passing an exam versus not passing an exam? Well, I've studied really hard, and I think I understand everything, so I think my chances are a lot higher of passing rather than not passing. So you can calculate probabilities and odds on lots of things. But again, it's a very simple equation. This is literally what SPSS is doing. You don't have to do this yourself. It'll basically pit the odds of success against the odds of failure. And again, you can flip it 4-1 or 1-4, depending on what you like to talk about. But most of the time, we like to look at the odds of success first and the odds of failure second. So that's really what an odds ratio is, okay? An odds ratio is just a way of comparing the probability of a certain event or outcome is the same for two groups or given some other criteria. So we get this conditional probability, okay? The probability of this happening given knowing this about you. Probability of Y given X. So what's the probability of getting a longer sentence given the fact that this is your 3rd offense, okay? Stuff like that. Those are odds of things happening. We can also do this with race when we look at kind of discriminant or indiscriminate sentencing. When we, look and say, do kids have it worse, or adults, or people of certain racial groups or ages or genders, do they tend to get sentenced longer? What are the odds of those things happening? These are the kind of tests we would run. So here's another one. Gender and arrest. So we want to know whether or not your gender makes being arrested more or less likely. So we could literally calculate this by hand. We have some data, we'll say, where we have everybody's gender, and then we ask them, were you arrested? Yes or no? So we want to kind of regress these two together to see if they have any kind of relationship to each other. So we can literally calculate by hand the odds for a male getting arrested and the odds for a female getting arrested, okay, by doing this little probability equation. Well, again, SPSS will do this for us. And when we make these calculations, we can say odds ratios. So, for example, in the data that I had, I found out that the odds of being arrested for a male are 5.44 times as large as the odds for a female. So, in other words, males are 5 times more likely to be arrested than females. Okay? Or you can say that females are less likely to be arrested than males. It's really saying the same thing, just in a different way. It just depends on who you want to talk about. Do you want to talk about males first or females? Okay? Describing an odds ratio, you could say, you know, that the odds of one group are more likely or the odds of the other group are less likely. It's really the same thing, just the flip of it, again, depending on how you want to focus your topic. Okay? So the cool part about logistic regression is the interpretation is super easy. Okay, it's much easier in many ways than linear regression. So it's basically, when you get that little exponential b, okay, that little odds ratio, if it's greater than 1, your outcome is more likely. If it's exactly 1, then there really is no difference between your outcome happening one way or another. Okay, if it's less than 1, then your outcome is less likely. Okay, so that's pretty much it. And you can say this in a lot of ways, depending on the group you're talking about, but that's all you really have to do. Okay, you also get what we call these logit coefficients. Okay, so we use an exponent of the logit. Basically what happens is we run a logarithm that kind of rounds off people's responses to basically it kind of takes it to the 10th or a natural log, and that's how we do these estimations. It's kind of complicated. I'm not going to go through it in detail. But that's what we get here. We get this logit coefficient, or this b, that's attempting to make a slope out of a line that curves. But again, it's not terribly meaningful by itself, so we use the exponential b. Okay? So remember, if you have a categorical dependent variable and you know, you have maybe a yes-no variable, like did you get arrested or not, did you get convicted or not, then yeah, this is probably the kind of regression you're going to run. The only logistic regression I teach in this class is binary, where you just have 2 categories. If you have 3 categories of things that could happen, you have to do what we call multinomial regression. I don't necessarily teach that in this class, but there is a regression for that. It's generally something you would learn in graduate study. So, so I kind of save that for another class if you continue on, because there's a little bit more to it. But this is kind of, we're already hitting well beyond the scope of this class, so you're already very well prepared to start doing some analyses. Okay, let's actually show you this in action, if I can get to my SPSS example here. Okay, so we have SPSS. Now what I did is I opened up the General Social Survey, okay, and I recoded 2 variables. I wanted to know the likelihood of someone owning a gun and whether some status about them could predict it as more or less likely. Okay, so right here, there's a variable called own gun in the General Social Survey. There's also a variable that's called denom, as in denomination. And I chose, just for funners, Southern Baptists. I thought they might be kind of interesting to study. And I was kind of working off a hypothesis or prediction that maybe culturally guns are more or less acceptable to certain faiths than other faiths. And so I wanted to see if this is actually true. So I can run a logistic regression on this. So here we go. You ready to see this? Analyze, and I'm going to go to regression and binary logistic. I'm going to put this stuff back that I kind of just put in there to show you. My dependent variable is whether or not you own a gun. Yes, no. So there's only 2 possible answers on that. I've already recoded it. And then my other variable is what we call Southern Baptists. Now, Southern Baptists were an answer choice in this variable where basically there was kind of a sequenced question that said, what faith are you? And it listed several faiths, and if they indicated they were Christian, it said, okay, what denomination of Christianity are you? And there was like 30 different denominations they could choose from, one of which was Southern Baptist. So I basically recoded this variable into setting the Southern Baptist aside compared to everybody else, just to see if being Southern Baptist made a difference. So let's find out if it does. So we're going to click OK. Here's the output. Okay, so you see right here at the top it says Logistic Regression. And then down here, you kind of have a whole bunch of boxes. This is how many cases you produce, so it tells you the N. We analyze about 2,000 people. You do need a lot of people in the sample to make sure this runs properly. So that is one requirement of logistic regression. You need a large sample size. Normally over about 300 cases is best. If you have less than that, then the technique probably won't work. You'll get errors. Okay, so that's one of the requirements. So then you get all this stuff. Okay. Then we scroll all the way down to the bottom. Okay, so again, the boxes in the top do what we call kind of a stepwise summary of some of the pieces being calculated. Ignore those for now. Whenever you get logistic regression, scroll all the way down. Train yourself to go all the way down to the output. It's these 3 boxes we're interested in. So here's the Cox and Snell. Here's the Nagle-Kirky. You can interpret this in a similar way to R-squared. Okay, you actually cannot mathematically calculate an R-squared, or what we call kind of how much variance can be explained, because you don't have a lot of variance to work with in logistic. You only have 2 possible answers. I own a gun, I don't. So this is an approximation of the variance. That's why we call it a pseudo R-squared. So it kind of says how well this variable does at describing your chances of owning a gun. We interpret it in a very similar way. I use the Nagle-Kirky value because it goes from 0 to 1, just like R-squared does. And you can, again, convert that to a percent. So take this little 0.042 times by 100. That's how much coverage you're getting in using this variable to explain gun ownership. So it's very low. It means there's a lot of other things that can explain gun ownership rather than just knowing your denomination. But that's basically how we interpret the R-squared. So, and Cox and Snell is a little bit different, but again, Nagle-Kirky is kind of the one people use the most. Okay, and then we go here at the bottom. I'm going to move this up. Okay, variables in the equation. Whoops, where'd my output go? There it is. So variables in the equation, there's our famous B that, again, we don't use. We like to go over here in the exponential B. Okay, this is the odds of something happening. So here you see Southern Baptist. That's my predictor variable. Knowing this about you lets me predict that about you. And we also have a significance level. Okay, so in logistic regression, you really only have to keep track of 3 things. The R-squared, the exponential B, the odds of something happening, and the significance level. That's it. That's all you have to do. So this 3.119, remember back in the slides we said that if your odds ratio is greater than 1, your outcome is more likely for one group than another. Well, 3 is greater than 1, so what does that mean? That means it's more likely. Okay, so basically what this is telling us is Southern Baptists, our ones inside this recoded variable, are 3 times more likely to own a gun as compared to other denominations of Christians. So yes, knowing if you're Southern Baptist does serve as a good predictor of whether or not you own a gun. On average, many people do, but again, not all Southern Baptists do, but we can use it as something that is predictive. Okay, it is a highly statistically significant variable, and that tells us this is a true relationship beyond chance. So essentially, that's how you'd interpret a logistic regression. It's a lot of fun to predict likelihoods of things happening, but if you have questions, let me know. I can go into a lot more detail as to how this kind of calculation is run, but essentially you're just predicting likelihoods of things happening or not happening. So if you have an outcome variable that's kind of that way, this is what you're going to run on your research paper, this kind of regression. So there are pros and cons to both linear and logistic. They're going to provide different amounts of information to you in different ways, but you have to make sure that your variables fulfill the criteria for what you're trying to test. Again, sample size and level of measurement. See you next time.